So I know that Dr. Zhang yesterday made an intro to like what is data mining, what kind of problems data mining has, and he covered some classification techniques, and he was going to make an intro to regression. So today, what I'm going to cover is I will cover classification. I will just talk about like what is classification algorithm, what does a classification algorithm does, and what kind of classification techniques are there, and also I'm going to cover two of the fundamental classification techniques. One of them is k-nearest neighbor algorithm, and the other one is logistic regression. So let's see like what is classification in general first. So assume that you have a table or data set. By table or data set, I mean we have like observations, we have columns, like each column is a variable, or it can be called like feature or attribute. And once we divide the data into training and test set, the goal is building a model using training data and trying to test and make predictions in test data. Now, again, given a collection of records we call training set, each record contains a set of attributes or variables or features, and one of the attributes is the class, or we can say that like dependent variable. The idea is using the attributes, we are going to try to explain or predict the dependent variable, which is the class. So the reason that we say this is a classification problem is that the column that we are going to explain or predict is a categorical variable. So let's say we have another data set and we have some attributes, and the dependent variable or the target variable that we are trying to predict is numerical variable, then we are talking about regression problem. So in supervised learning in data mining, there are two types of problems, like main problems. One is classification, the other one is regression. And the main difference between them is the type of dependent variable, the type of the target variable. So in classification, the target variable is a categorical variable. If it is a numerical variable, then it becomes a regression problem. So we find a model for class attribute as a function of the values of the other attributes. And the goal is previously unseen records should be assigned a class as accurately as possible. So here's again an example. So in this case, we have 4 attributes. Each row is an observation, and we are going to use these 3 attributes, attribute 1, 2, 3, to predict the class of each observation. And as you can see, for the training data set, we have the true labels, true classes of each observation. What we are going to do is we are going to build a model using this training data, and then we will try to predict the classes of unseen observations. And some examples of classification tasks includes like predicting tumor cells as benign or malignant, classifying credit card transactions as legitimate or like fraudulent, or classifying the secondary structures of protein as like alpha helix, beta sheet, or random coil. So somehow we're classifying them, or categorizing news stories as finance, weather, entertainment, sports, and etc. Like another application that you are using probably every single day is like, let's say if you're using Gmail, you have that spam folder, right? And some emails goes to that spam folder, some emails go to your inbox. So that is actually a classification problem. Like the email, when an email comes, the algorithm decides if the email should go to spam folder or inbox. And there are many classification techniques, and we can categorize them as like decision tree based methods, rule based methods, like memory based reasoning, neural networks, naive based, and support vector machines. So these are just a few.